So here we have lesson 2-4, which is on graphing vertex form. And we're going to look at all transformations within vertex form for this lesson. For our essential question, you need to describe the process of graphing a function in vertex form. Excuse my typo. So there's no vocabulary for today's lesson, nothing new for us to talk about. We're going to be using vertex form just as we have been over the past couple of lessons. So given first an equation, y equals 2 times the quantity of x plus 5 squared minus 4, we need to graph this equation. Now, when we have an equation in vertex form where we have all these different values attached, the first thing that we need to do still is to identify the vertex. So we want to identify the vertex of our function here. And the vertex here is going to be, remember, it's the opposite of what we see inside the parentheses, and the k value is here. So our vertex is -5, -4. So again, first thing we do is identify the vertex. Make sure that you guys are reserving the right-hand column about 2 inches for the toolbox. Even though I'm not physically typing it out for you, you need to make sure that you're adding stuff to the toolbox as we go. So when I'm giving you those verbal directions, make sure you're adding that stuff to the toolbox. So identify your vertex. From there, we want to identify the A value. Now, the A value gives us 2 different pieces of information. The first piece of information the A value gives us is whether the graph opens up or down. So because this is a +2, we know that our parabola is going to open up. And the second piece of information that we need to use the A value for is our graphing pattern. Now we know that the graphing pattern for when A is equal to 1 is 1, 4, 9, 16, etc. But remember, like we discussed in lesson 2-3, when your A value is no longer 1, we have to take our A value and we have to multiply it to our pattern. But when we multiply it to our pattern, we only multiply it to the numerator. So the 1, 2, 3, 4 in the denominator isn't going to change because that's the movement. That's each step's movement. So that's always our over number. So we're going to take the A value, which is 2, and we're going to multiply that value to our numerator. So our first graphing pattern number is going to be 2 over 1. Then we're going to have 8 over 2, 18 over 3, and 32 over 4. Clearly, this is going to be way too big for us to put on our graph, so we're not going to have to worry about that one, but we will check to see if we can fit the 18 over 3 on our graph once we have our vertex there. So we can go ahead and put our vertex on our graph. Our vertex is at -5, -4. So go ahead and plot your vertex on your coordinate plane. Make sure you are using graph paper. Once we have our vertex, remember we always need to draw our axis of symmetry through the vertex. So I'm going to go ahead and draw my axis of symmetry through the vertex and identify it. We're crossing the x-axis at -5. So our axis of symmetry is x equals -5. Then once we have that, we can go ahead and apply our graphing pattern. So from the vertex opening up, our first movement is up 2 over 1 in both directions. Then going back to the vertex, our next movement is up 8 over 2 in both directions. And the next movement is up 18, which would end up putting us off the graph because that only gives us 14 spaces here. And so we're going to have to stop at the up 8 over 2. We can go ahead and connect our points, making our parabola shape. And here we have our parabola with multiple transformations. And we're going to go ahead and we're going to describe that in just a second. So we identified our vertex, we identified the A value and whether it opens up or down. Then Depending on what the A value is, we have to change our graphing pattern by multiplying the A value to the numerator of our parent function graphing pattern. So that's where we got these numbers here. And then once we have that, we can put our vertex and axis symmetry on the graph and apply our graphing pattern to find our next few points. Now we're going to have to continue to explain how this graph differs from the parent function. So for this graph here, the first thing I'm going to explain is that it translates to the left 5 and down 4. And then because our A value is 2, there's going to be a shrink or stretch. Now remember, like a rubber band, when it gets narrower, that's like we're pulling up on the rubber band, making it stretch out. So this is a vertical stretch of 2. And that is the transformation from the parent function. Again, make sure you have stuff in your toolbox. Let's take a look at another one. All right, so same steps here. First thing we want to do is identify that vertex. So our vertex comes from this 5 and 7. Remember, inside the parentheses, we change the sign. It's the opposite of -5, which is going to be a +5. And our K value is a +7. Our A value is -1/2. Again, that tells us two pieces of information. First, it tells us that our graph is going to open down because the A value is negative. And the second thing this is going to do is it's going to change our graphing pattern. Because A is not 1, we have to go ahead and multiply all of the numerators in our graphing pattern by 1/2. So for this, if I multiply the 1/2 to the numerators, that's going to give me 1/2 or 0.5 over 1. 1/2 times 4 is 2 over 2. 1/2 times 9 is 9 over 2 or 4.5 over 3. 1/2 times 16 is 8 over 2. And 1/2 times 25 is 25 over 2 or 12.5. Oops, this should not be a 2, this should be a 4. Eight over 4 and then 12.5 over 5. So again, your denominators, those are always the numbers that you're going to move over from the axis of symmetry, and those should always be consecutive numbers, 1, 2, 3, 4, 5, etc. Remember, we always use what we can fit on our graph. So we're going to start with our vertex at +5, +7. Go ahead and include your axis of symmetry. The axis of symmetry is x equals 5 in this case. Now from our vertex, we're going to move in the downward direction because our A value is negative. Our parabola needs to open down, and we're going to use our new modified graphing pattern to find the next few points. So from the vertex, I'm going to move down a half a space and over 1. Back to the vertex, I'm going to move down 2 spaces and over 2 in both directions from the axis of symmetry, remember. Back to the vertex, I move down 4.5, so 1, 2, 3, 4 and a half space, and then over 1, 2, 3. We're still between those two numbers because it was just a half a space, so be careful. And then we're going to move down 8 spaces and over 4. So down 8 spaces over 4. And then our last one is 12.5 over 5. 12.5 over 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Go ahead and connect your points. And that is our parabola. So again, we want to talk about how this graph has transformed from the parent function. So the first thing we need to mention is that is a reflection because this graph is opening down. This graph has been reflected across the x-axis. The next thing we need to talk about is the fact that the vertex has shifted from the origin. So we need to say that the graph has translated to the right 5 and up 7. And lastly, because our a value is not 1, there is again a shrink or a stretch there. Remember, when your a value is between 0 and 1, or when our parabola gets wider, that's what we refer to as a vertical shrink. So the graph is a vertical shrink of 1/2. And that is graphing in vertex form, where we put all of our different transformations together. Make sure, again, you have stuff in your toolbox.